Scalar quantities. Scalar quantities are physical quantities that can be described by a single value, or a physical quantity that can be described only by its magnitude, numerical value, is called a scalar quantity, such as mass, temperature, time, and energy. These quantities do not have a direction associated with them and are represented by a single numerical value. Vector quantities. Vector quantities, on the other hand, are physical quantities that have both magnitude, size, and direction. Examples of vector quantities include displacement, velocity, acceleration, force, and momentum. These quantities are represented by a vector, which is a mathematical object that consists of a magnitude and a direction. In summary, scalar quantities are described by a single value, while vector quantities require both magnitude and direction to be fully described. Speed. Speed is a scalar quantity that refers to how fast an object is moving. It is typically measured in units of distance per unit time, such as meters per second, meter per second, kilometers per hour, kilometer per hour, or miles per hour, mph. Speed can be either constant, meaning that the object is moving at the same speed throughout its motion, or variable, meaning that its speed is changing over time. It is important to note that speed only describes how fast an object is moving and not the direction of its motion. To fully describe an object's motion, you also need to consider its velocity, which is a vector quantity that includes both speed and direction. Speed equals distance, time. Types of speed. There are two types of speed. 1. Uniform speed. 2. Non-uniform speed. 1. Uniform speed. Uniform speed refers to a situation where an object travels at a constant speed over time. In other words, the object moves the same distance in the same amount of time over the entire duration of its motion. For example, a car traveling on a straight and flat road at a speed of 60 miles per hour is moving at a uniform speed. 2. Non-uniform speed. Non-uniform speed, on the other hand, refers to a situation where an object's speed varies over time. This means that the object moves different distances in the same amount of time or the same distance in different amounts of time during its motion. For example, a car traveling in a hilly area may have to slow down or speed up depending on the gradient of the road, which means it is moving at a non-uniform speed. In case a body has a non-uniform speed, we calculate its average speed. Average speed. Average speed is the total distance traveled divided by the time it took to travel that distance. It is a measure of the overall rate at which an object has moved over a given distance, and is usually expressed in units of distance per unit of time, such as miles per hour, mph, kilometers per hour, kilometer per hour, or meters per second, meter per second. Mathematically, average speed can be calculated using the following formula. Average speed equals total distance traveled divided by total time taken. For example, if a car travels a distance of 300 miles in 5 hours, its average speed would be average speed equals 300 miles divided by 5 hours equals 60 miles per hour. Velocity. Velocity is a physical quantity that describes the rate of change of an object's position over time. It is a vector quantity, which means it has both magnitude and direction. Velocity is represented using the formula v equals dt, where v is velocity, d is the distance traveled, and t is the time taken. There are two main types of velocity. 1. Uniform velocity. Uniform velocity refers to the velocity of an object that travels a constant distance in a fixed amount of time. In other words, the object is moving at a steady speed in a straight line. The magnitude and direction of the velocity remain constant throughout the motion. For example, a car traveling at a constant speed of 50 km per hour on a straight road has uniform velocity. 2. Non-uniform velocity. Non-uniform velocity refers to the velocity of an object that is changing in either magnitude or direction over time. In other words, the object is not moving at a constant speed or in a straight line. The magnitude and/or direction of the velocity is changing throughout the motion. For example, a car that is accelerating or decelerating has a non-uniform velocity. Similarly, an object that is moving in a curved path or changing its direction has a non-uniform velocity.